Okay, this is an answer key video for the Constructing Quadrilaterals worksheet in preparation for our upcoming SWIC on quadrilaterals and coordinates. So, we're constructing quadrilaterals. Those are four-sided polygons. And there's always a series of different criteria. So it's either going to be side lengths or angles, things like that, that you're going to have to incorporate into your quadrilateral. And at the end, once you've drawn it to scale, then you have to classify it. So in this first one, what I like to do is just draw a little sketch over on the side. And it doesn't matter if the sketch doesn't really look like the actual one, but it gives me some insight into how this might look in the end. So quadrilateral QRST, that means QRST, it'll go in that order. Now, QR and TS are the same length. That's what this means, QR and TS. So this here and this, excuse me, side length are the same length, and they're both 5 centimeters. And QT and RS are the same, and they're both 4 centimeters. All the angles are right angles. Okay, so I can already sort of see that it's going to be a rectangle, but I have to draw this to scale. So what I'm going to do first is I'm going to start off with my QR. So I'm going to draw it so that it's 5 centimeters long. And then I have to draw a 90-degree angle here and here. So I'm going to use my protractor. And then these side lengths are going to be 4. So I'm just going to set up my ruler here, line it up with my dot for my 90 degrees, and go 4 centimeters here and 4 centimeters towards this dot. So I know that these are both 90-degree angles. And then this should be 5 if I've done it correctly. Okay, so it's 5 centimeters across here, and these are right angles as well. I have to label all of my vertices and make sure I include all necessary geometric markers. And this is a rectangle, as I saw in my little sketch at the beginning. Might be also useful to write down the side lengths in your diagram. You don't have to write 4 centimeters over here because there's already a tick here that indicates that they're the same. And same way, you don't have to write 5 centimeters here because I already wrote it here, and the ticks show that they're the same. In question 2, this sign here means parallel. So AB is parallel to DC. I'm just going to construct my quadrilateral ABCD over here. And I know that AB, this one, has to be parallel to DC. So these two are parallel. AB is going to be 8 centimeters long. BC is going to be 6 centimeters long. CD, this one here, is going to be 4 centimeters long. Angle B, this one, is going to be 60 degrees. And angle C, which is this one, is going to be 120 degrees. All right, so there's a couple questions that you have to answer once you sketch it. But I have my little sketch here. And so what I like to start off with is angles. So I'm going to draw this 60-degree angle, but I'm going to start off with AB first. So I'm going to draw my line AB that's 8 centimeters long. Oops. This isn't the best ruler here. Okay, so this is AB, and it's 8 centimeters long. Then this angle B right here has to be 60. So I'm going to use my protractor. Some of us are still having trouble with the scales on the protractor, making sure we read the right one. So if we start here and I want this to be a 60-degree angle, you want to remember that 60 degrees is going to be an acute angle. So I'm going to be reading the scale that starts at 0 and working up here to 60. Okay, so here's 60 right here. Now I want to go from B towards this point, which is the 60-degree angle, and I want to go for 6 centimeters. So I'm going to line up my B at 0, and then I'm going to make sure my ruler is going to pass through this point down here, and I'm going to go in this direction for 6 centimeters. So this is 6 centimeters, and this is 60 degrees, and I got down to point C. The next thing I have is that this angle is 120 degrees. Okay, so I'm going to use my protractor again to find a 120-degree angle. I'm starting at 0 and I'm working around until I get to 120. And then I'm going to go in that direction for 4 centimeters. I'll have to do it this way. I'll go this way. Oops, flip it around. So I'm going to start at C, and I'm going to go 4 centimeters in the direction of my dot that I just put. So this here is 4 centimeters long, and I got to point D. So let's see here. So AB is parallel to DC, so I'm going to put my parallel indicators, so that's good. AB is 8 centimeters, BC is 6, CD is 4, B is 60, this one is 120. And now I just have to complete the quadrilateral by connecting these 2 points. And so I have my quadrilateral A, B, C, D. And when I'm looking at this, I notice that there is 1 pair of parallel sides. There aren't any right angles, there aren't any equal side lengths. So this one here is just a normal trapezoid. And then the last question is, what is the length of AD? And so this is where I'm going to take my ruler and I'll measure from A to D, and I get it pretty close to 5 centimeters. So I'm going to say around 5 centimeters. Okay, you could also say 50 millimeters if you want. You might be close to that. So around 5 centimeters, maybe you'll have 48 millimeters or whatever. On the other side of the page, I want A, B, C, D. So same thing, I'll just do my A, B, C, D. AD is 4 centimeters, so this one is 4. AB is 6 centimeters. Angle A is 90 degrees. Angle B is 55 degrees. And AB is parallel, so these are parallel. All right, so I want to start drawing this. I have an idea of what it's going to look like anyway. If you want in your preliminary sketch, like because this is 55, it'll actually be more like this. And so I can already sort of see that it's going to be probably a right trapezoid, but I have to draw it to scale as well. So it's always beneficial to draw like a little sketch on the side because it'll help you predict and what it's going to be and where to put your measurements, because these can be really confusing with all the different criteria. All right, so I'm going to start on top. Again, AB is 6. So that's 6 centimeters from A to B. And then this angle here needs to be 55. And this angle here needs to be 90. So I'll use my protractor. So 55 degrees, if I start at 0 and I work up to 55, it's going to be right here. And for 90, it's going to be down here. Now the other measurements that are given is that this length here is 4. So I'm going to start at A, and I'm going to work down 4 centimeters towards, look on my diagram, this is going to be D down here. AD is 4, AB is 6, angle A is 90 degrees. And in this case here, what I'm going to do is I'm just going to draw a line. It doesn't matter if it extends past. The quadrilateral doesn't have to be like a perfect closed structure with no overhangs or anything like that. So C is going to be down here. And the last thing is that this is going to be parallel to whatever this line is here. So that means that this has to be 90 degrees as well. You could use a protractor to do it. So that's going to be 90 degrees. That's 55, and this is point C. So it's okay if these overlap. You can still see a quadrilateral here. So this is a right trapezoid, and the length of BC is around 5 centimeters or 50 millimeters again. Okay, question 4. I have ABCD. AB is parallel to DC. AB is 4 centimeters, and so is DC. So this is also 4 centimeters. AD is 5 centimeters, and BC is 5 centimeters. But unlike the first one where it ended up being a rectangle, angle A is actually going to be 60 degrees. So it's going to be sort of like that instead. Okay. And then if I look at this, if I see that this is going to be 4 centimeters, this has to be the same length. So it'll probably go to about here. So I'm thinking it's going to be a parallelogram, but let's see how it goes. I'm going to start with my top again. So a 4 centimeter line from A to B. A to B, that's 4 centimeters. And then in this case here, I'm actually going to do this angle next because that's sort of the next most important measurement. So I'm going to get my 60 degree here. I'm starting at 0 and I'm working up to 60. So I'm going in this direction. And I want to go 5 centimeters in that direction. So I'm going to line up all my dots and I'm going to go 5 centimeters here, that's to here. And that's D. And this is the 60 degree angle. And then this one is going to be parallel to that. And this one here is going to be parallel. Now, I don't know if I did a great job here. I could use my protractor as well and make sure that this is heading in a 60 degree direction as well, so it should actually be more over here. I'll correct that a bit. So this is point C, so A, B, C, D. This is parallel to this, and this is parallel to this. And this is also 5 centimeters and 4 centimeters. So this is a parallelogram. What is the value of angle D? So now that I have angle D here, if I were to take my protractor and measure it, angle D is about 120 degrees.